All right, so now we're going to move on to calculus with parametric equations. So parametric equations means x is in terms of t and y is in terms of t. All right, so how we're going to find the slope, because that's what we like to do, right? So we did first with calculus, is find dy over dx, and dy over dx is really just defined as dy over dt over dx over dt. And I can easily show you that if you multiply by the reciprocal, oh, look at that, it's dy over dx. Okay. So if you're given information about the function, actually it doesn't have to be a function, it could be a curve. Remember, a function has to pass the vertical line test. It doesn't have to be that, but we're given information about this curve, and I want to find y prime. I want to find the derivative of y, so I can see that the derivative of y will be 1/2 t over the derivative of the x, which will be 1/2 t to the negative 1/2. And I'm just going to fix that. The 1/2s I see cancel. I'm going to multiply by the reciprocal. So I get t to the 3/2 power. All right, so now I'm going to evaluate it at t equal 4. So I'm going to put 4 in. So I get 4 to the 3/2. So square root of 4 is 2, and then cube it is 8. So that's my slope. And that's all it's asking for. Oh, that's all it's asking for here. Down here, it's asking for the equation. All right, so I know that m is equal to 8. How do I find the point? If I'm finding an equation of a line, I need an x and a y point. Well, these x and y points happen at this particular t value. So I put this t into the x. So I get 2, and I put this t value into the y. 16 minus 4, so that's 1, that's 12. Divided by 4, that's 3. All right, so I get 2, 3. So putting that together into the equation of a line, there it is. All right. So let's do another one. So this is saying find the slope of the tangent line. Seems very familiar. So let's go find the derivative of y, which would be 1/2 over the derivative of the x, which will be 2t. So let's fix that, right? So 1 over 4t. This is different. They're not giving me a t value. So I need to find out what t is. Or do I? I do need to find out what t is so I can plug it into here, right? I've got my xy point, so to find the equation, I know it's y minus 1 is equal to slope x minus 0, right? But in order to find the slope, I need a t value. So this is where I know that x is 0, and x is equal to t squared minus 4. I know that they're giving me y is 1, and y is equal to t over 2. So between the two of these, I should be able to come up with one t value. So I think t is equal to 2. Yes? Okay. So t is equal to 2, so I can get the slope of 1/8. So now I can put together the equation of my tangent line. All right, let's find where the slope of the tangent line is horizontal. So what does horizontal mean? Horizontal means slope is equal to 0. And so if I'm looking at dy over dt over dx over dt for y prime, I want the numerator equaling 0, and I have to make sure the denominator does not equal 0, correct? So I do need to find both parts. So let's go find y prime. So I have 4t cubed minus 6t over 3t squared plus 2t. So just trying to see if there's anything in common. Let's factor some things out. So if I factor out 2t, and let's make sure I did that right. Yep. And then if I factor on the denominator a t, so t's will cancel, correct? So I can't use t equals 0 for the numerator. So do the canceling like you need to. Now I'm going to set the numerator equal to 0 because that's where my tangent line will be horizontal. T squared will equal to 3/2. So t will equal to plus or minus root 3 over 2. All right, let's look at this one. So y prime, so 3t squared minus 3, 2t minus 2. Let's factor a 3 out. And if I factor a 2 out, I see the difference of squares. Do you? T plus 1, 2t minus 1. So these are gone. So all I'm left with is this. So when is the numerator equal to 0? Well, that would just be at t equal -1. So it's just asking me for the t values, right? If you were being asked for the xy values, you would just put this t back into the xy, correct? If you were asked, just to make sure you knew that. All right.